All right, number 5, graph the function, and we've been given a piecewise function, and we have f of x equals 3 if x is greater than or equal to 1, and we have f of x equals negative 4 minus x if x is less than 1. Notice that both the domain restrictions here revolve around positive 1. All right, so we have two xy tables. The first xy table here is for the first piece. The second table here is for the second piece. If this piecewise function had 3 pieces, we would have 3 xy tables. If it had 4 pieces, we'd have 4 xy tables. These tables here just help us to stay organized when it comes to finding points and then plotting them. All right, so again, the domain restriction revolves around positive 1 for both pieces here, and so we're going to let x be positive 1 for both of these tables. And let's fill in the remaining x values for this first table here, which deals with f of x equals 3, this first part. And we're interested in x values that are greater than or equal to 1. Greater than or equal to 1. So what are some numbers that are greater than 1? Well, 2 is greater than 1, 3 is greater than 1, 4 is greater than 1. All right, let's find the corresponding y values when the x's are 1, 2, 3, and 4. All right, if we're using f of x equals 3 and we want to find f of 1, notice that there's no x value, or variable rather, to plug any number into. It's just a 3. It's not 3x. It's not 3x plus or minus something. It's simply a 3. So what that is telling us is that this is a constant part of the graph. This is a constant function. No matter what the x value is, the corresponding y will always be 3. All right, so that was relatively straightforward. Not a whole lot of calculations to do there. And if we take a look at the second part here, the second xy table, we are dealing with a domain restriction for x less than 1. All right, so some numbers less than 1, well, 0, negative 1, negative 2. And if we want to find the corresponding y values for each of these x's, let's take the x value and plug it in and find out what we get. All right, so if we're evaluating f of 1 equals negative 4 minus x, well, we know negative 4, and we'll distribute that minus through, minus 1 equals negative 5. So when the x value is 1, the y value is negative 5. All right, let's find out what the corresponding y value is when x is 0. So we're going to find f of 0, and so we'll have negative 4 minus 0. We can distribute there, so negative 4. Well, negative times 0 is just a 0, so we can say minus 0 plus 0, doesn't really matter. And we know that'll end up going away anyway, and so we have negative 4. So when x is 0, the corresponding y is negative 4. All right, how about negative 1? Well, let's see. So we're going to have negative 4 minus negative 1. We need to distribute, so we end with negative 4 plus 1. That gives us negative 3. And we could go ahead and find out what the y value is when x is negative 2, but it looks like we have a pattern here, don't we? So we would expect the next y value to be negative 2. As the x, notice, as the x decreases by 1, the y is increasing by 1. All right, so we've got both of our tables filled out. Let's go ahead and plot all of these points. It's important to take note of the domain restriction and the inequality used for each of these pieces in the function. Notice this first piece here, f of x equals 3, the domain restriction was x is greater than or equal to 1. So this point here, 1 comma 3, when we graph it, we're going to graph this point with a closed circle. And for the second piece here, f of x equals negative 4 minus x, we had x is less than 1. So this point, 1 comma negative 5, will graph with an open circle. All right, so 1 comma 3, we're going to graph with a closed circle. 2 comma 3, 3 comma 3, 4 comma 3, and that trend will continue. So there is the constant part of the function. And here we have 1, negative 5, 1, negative 5 down here, but again, Make sure to graph with an open circle. 0, comma, -4, -1, -3, -2, -2, right there. And that trend will continue. Oh, that's pretty bad. Let's try a little better, something like that. It's difficult to draw a straight line freehand, but this is what we have here. We have two pieces to the piecewise function. We can see a big jump here. There's a discontinuity here in the graph, but we have our constant function here. So this is f of x equals 3, and here this part of our function is f of x equals, and I think I'm going to run out of room, so f of x equals -4 minus x. All right, there's number 5. I'll see you at number 6.